So in this video we're going to look at some trigonometric differentiation, the derivative of sin x and cos x. So if we think of the function of sin x and we were to sketch the curve of sin x, we know that it starts at 0, goes up to a maximum of 1 at 90, down to 0, a minimum of -1 at 270 and finishes at 360. So in a previous video we've looked at graphing the derived function. So if we were to look at where the stationary points on this curve are at, so we've got 1 at 91 and 1 at 270 -1, we know that the gradient at each of these points is 0. So if we were going to plot the derived function, they would both lie on the x-axis. Then we have to consider what's happening to the gradient before and after our stationary points. And so if we were to sketch in our derived function curve, we've actually ended up with the curve of cosine of x. And so the derived function of sine of x is the cosine of x. Now if we do the same thing where the function of x equals the cosine of x, so this time we're going to start with our cosine curve, which begins at 0, 1, has roots at 90 and 270, and a minimum at 180, -1, and another maximum at 361. If we look at our stationary points, where we know the gradient is 0, we can graph our derived function because at 0, 180, and 360, the graph of our derived function is going to lie on our x-axis. And then we need to consider before and after our stationary points to determine what happens in between these roots of our derived function. And you can see that when we join them together, we end up with a reflection of our sin x curve in the x-axis. So it means that the derivative of our function x with respect to x is negative sin x. And these relationships are on our formula sheet. Now in the example, we want to find the derivative of the function of x when f of x equals 2 sin x, which means we've got f of x equals 2 multiplied by sin x. So the derivative of f of x with respect to x is 2 multiplied by the cosine of x, and then we just remove the multiplication sign, so the derivative of this function is 2 cos x. Now in the next example, we want to find the rate of change of r equals 3 sine theta minus 5 cosine theta at theta equals pi over 2 radians. Now it's asking us for rate of change, and we know that that means we need to differentiate. And the reason that theta is given in radians is because we cannot evaluate trigonometry unless our angle is in radians. So we've got r equals 3 sine theta minus 5 cosine theta, and that means that the derivative of r with respect to theta equals 3 cos theta minus 5 times negative sine theta. And then we need to simplify it, so we get dr by d theta equals 3 cos theta plus 5 sine theta. Now, we need to evaluate when theta equals pi over 2, and so we need to consider the curves of sine theta and cosine theta. So if we quickly sketch these, our sine theta curve has a value of 1 at theta equals pi over 2. And for our cosine curve, at pi over 2, our cosine curve has a value of 0. And we're going to substitute theta equals pi over 2 into our rate of change. So dr by d of pi over 2 equals 3 cos pi over 2 plus 5 sine pi over 2. And so 3 multiplied by 0 plus 5 multiplied by 1 is going to give us a rate of change for this function of 5.